Well, I think this is it. Can everybody hear me? And what I was going to suggest is that we have such a small group. We just introduce ourselves to one another. I'm Curtis Baysinger. I've been a member here since 2004. I think everybody in the room knows me, so I'll be quiet after that. I'm kind of the head of our small Earth Care Task Force here, and so. And you, okay, got it. Got it. Great. Got it. Okay, got it. Wonderful. And we're just introducing ourselves, 2 lines on who we are. Got it. Thanks. Let me just say that this is probably the 8th time I've been involved, or we've been involved in presenting material on this topic. That includes the 2 times that we had, one time we had Will Wellman come and talk about faith-related issues, and Nate Stuckey, who is a friend of his that he knew in seminary that runs essentially the Earth Farm at Princeton Seminary, and I'll just a little bit later on what we said there. I'm going to do this as a review. I'm going to move fairly quickly, and I hope it's a review for you all. And then we're going to, at the end here, I think I want to talk and engage in a discussion about what we as a congregation can do about one central topic that I think is important for us to engage in individually and as a group. I love this cartoon. It was published during the height of the COVID, and it pointed out that even though the Earth was battling COVID, or at least humanity was, a far larger threat was climate change. And it certainly, in terms of the way it's magnified and larger, it does pose a greater threat to humanity. And that leads to perhaps reactions on our part individually and as groups that are not beneficial, but it can certainly help motivate us. So I'm now going to spend just a little bit about talking about why it really is us, that humanity is the cause of it. And the lines of thinking, and I'll just present a few of them. There are probably about 2,100 indicators that humanity, fossil fuel use, is driving what we're seeing around us. And the first, at least demonstrated by the graph, is that you notice that the rise in atmospheric carbon dioxide, which is the driver of temperature increase, is almost lockstep, certainly since the 1900s, with the fossil fuel emissions that humanity has exhibited. And if you look at the graph to the right, you notice that carbon dioxide as a percentage really hasn't increased over the last, at least almost the last million years, and has been really out of proportion, and the temperature rise has been out of proportion since. At the end of this graph, you can see the dramatic rise due to fossil fuel use. Further evidence of that is that you can see that the temperature of the globe, and it's interesting, how can I tell what the temperature was 700,000 years ago? And the answer is very wonky, and based upon ice core samples that have been taken from Antarctic and the Arctic. But pretty much you can see here the temperature in CO2 has been in lockstep with one another throughout the entire time over the last million years. And it's only our use at the end that has driven temperature rise excessively, and that has been due to human fossil use. You can model this. One important thing to look at the graph on the left is that the observed warming that has occurred actually has started to decline. And 1,000 years ago, before we started emitting CO2, the natural astronomical and Earth orbital pressures that would have caused us to start to have a natural cooling was beginning. And if you look at the graph on the right, you can see that we have now distorted that, and that you can separate out what we have created from what would have been created from those natural things. If at any time I confuse you, because I'm covering an awful lot of ground here, please raise your hand. But up to this point, have I been clear? Okay. Correct. It was CO2. And this gets into the work on paleoclimatology, looking for indicators in the past of what, because your question is an important one. Temperature rise occurred, and what I've shown you here is a correlation, right? I've not shown you causative effect. If indeed temperature rise is due to CO2, then prove it, because all I've done really is show you correlation. And have there been drivers of temperature change in the past that are not CO2 related? And the answer to the second question, I kind of already showed you. They've been in equilibrium for one another, at least for 1 million years, if not longer than that. The answer to the first question is science, showing that if you put CO2 and do an experiment or laboratory experiment, you can show that the amount of heat within that gas will rise due to when sunlight hits it, because CO2 absorbs energy in the infrared, which is what the Earth surface and water emits back to the atmosphere. The second thing that shows that is the I'm getting wonky here, but it's the radioisotopic mixture of the carbon itself. You can directly correlate changes in the atmosphere, at least the radioisotopic signature of carbon in that atmosphere, and the ratio has been significantly altered as a result. And you can look at the gases that trapped in Antarctica and show those same changes as well. So the answer to your question is complicated, Ken, and those are the lines of evidence that suggest that CO2 itself is a driver of it and the main driver of it. Did I answer your question? Okay. Oh, what has caused it in the past? Okay, and the answer is that as the temperature of the globe increased, okay, due to astronomical variation, the vegetation and the Earth's natural sorts of sinks and exposures led to a net rise in carbon dioxide through greater photosynthesis that occurred and greater deposition. So yes, there is evidence in the past that temperature, and I'm sorry I misstated this, astronomical changes themselves will change the amount of sunlight and the net energy balance for energy that hits the Earth. That in itself, because of the way it affects the way the plant cycle works and the way the ocean cycle works, et cetera, will increase CO2 levels. Those CO2 levels actually cause a positive feedback cycle that creates more photosynthesis over time until the natural astronomical cycles started a cooling again. So it's yin and yang. They're correlated to one another. They've been in equilibrium. And some are causative and others are not. But clearly, CO2 by itself amplifies the heat and warming that occurs on the Earth's surface due to the Earth's surface. So we can estimate how much the effect of human fossil fuel use will lead to warming, and something called the Intergovernmental Panel on Climate Change meets every 2 to 3 years, and they reassess the models that are used to forecast what these rises might be. And over the last 15 years, they pretty much indicated that the mean of that is a little less than 3 degrees centigrade, as shown on this graph. And if you look at the bars, it shows that that has a very wide variation. And in fact, what gives me great confidence that these models are correct is that all these models, particularly the ones that were generated back in the 1970s and the later ones that have been generated past 2000 into 2020, and further refinements of them that have occurred over the last 4 or 5 years, pretty much indicates the same thing. And within a very broad, not broad, within a relatively narrow band, they all indicate the same and predict the same amount of temperature rise that has been observed. So the models that have been created are accurate to the historical record. And they can be even used to model situations that occurred on the Earth back during that 1 million year period that I showed you earlier. So now I'm going to say something here that's a little political. And it has to do with what ExxonMobil knew. Because this testimony occurred, Martin Heffert gave a testimony to Congress now about 5 years ago, while a House committee was trying to investigate what the oil and fossil fuel companies knew about climate change at the time that they were in business. And it's clear that ExxonMobil had hired a relatively sophisticated group of climate scientists. And Martin Heffert, who is now at Columbia or retired from Columbia, professor emeritus of geophysics there, was one of the people that was in that group. And this is a graph that ExxonMobil created in 1982. And I want you to look at it just a little bit. The bottom part of it, the bottom axis says 1960 to 00, is 1960 to the year 2100. And notice if you look at the year about 2030, which is kind of in the middle of the graph, go up and then look over to the left, you can see that they actually predicted that fossil fuel, or rather carbon dioxide concentrations in the world would be about 430 parts per million, which is kind of close to where we are right now, which is about 422. And if you look at the graph over to the right, which is the temperature increase, you notice that it's about 1.3 to 1.4 degrees centigrade, which is about what we are at this point. So their prediction was that fossil fuel use would grow, and that we can predict that this would be about the amount of carbon dioxide rise we could see and the amount of temperature rise we could see. It's pretty clairvoyant. Why they didn't recognize this as an opportunity to stop being a fossil fuel company and being an energy company is beyond me. And Martin Heffert in this testimony asked that question. Why did they not do that? And to say that we haven't recognized this for a while, I want you to look at the number down at the bottom here, 1955. Well, that was the year this paragraph. How many of y'all got Time Life books when you were young? Okay. Do you have the you the 1955? Huh? Came to the house, didn't it? Well, this was in one of them. It was on the natural world, the world we live in. This paragraph was in there that I'm going to read just part of it. It said, for the last temperatures have shown an upward trend. Well, we recognize that in the 1950s. Okay. One suggested explanation is an increase in the carbon dioxide content of the atmosphere. In the last century, the carbon dioxide ratio in the atmosphere has increased by 10%. That was about right. It increased from about its average of 280 up to about 300 parts per million. Phenomenon that's some attributed to expanding industry, that 6 billion tons of carbon dioxide were emitting in the atmosphere every year. They didn't speculate on where it was going, and we're not going to do that today. So 1959, we kind of knew. One of the things that we talked about was what our children and grandchildren would see. And if you look at the bottom of this, the top part of this graph represents area or years that the temperature was less than the average from 1900 to 2100. And notice that over time, the years themselves have been increasing in temperature compared to that average. This graph was created in 2020 with the last IPCC report. Actually, there was one that came out in 2023, but I haven't updated the slide yet. Notice that if you look at high, very high, intermediate, low, and very low carbon dioxide emissions, you can forecast what the temperature rise will be. And it increases with the amount of CO2 we emit. And it puts in graphic form how it relates to people over generations. Now, most of us, with some very good exceptions, we're at the bottom here. I'm in 73, so I'm at the bottom here, and I'm seeing that towards the end of my life. But a baby born today is likely to see temperatures that are very, very excessive. And given the fact that extremes of temperature are only going to arise, will be exposed to increasing life-threatening, temperatures. And that's what keeps me up at night. If you look at this graph, you notice that it's skewed to the right. The area under the curve, does everybody know what I mean by that? It's a measure of what the likelihood of that is. And notice that there is a significant likelihood, 15 to 20%, that the temperatures will exceed 4 degrees centigrade, which is civilization ending as we know it. So what keeps us up at night? It's that there are factors we don't understand that are driving temperature rise, and that the Earth, atmosphere, ocean system, which are the primary drivers in interaction thereof, that determines the temperature rise from a given level of carbon dioxide, will be far higher than what we predicted, because we either didn't incorporate it or the models that we have are wrong. And an example of that has been the last couple of years, 2023 and 2024. If you look at the graph to the left, 2023, from the start of it, or rather June of 2023 through May of 2024, temperatures on average have been 1.6 degrees centigrade higher than they were from the baseline measured from 1850 to 1900. That's shown on the left, and a more kind of string chart where you look at average temperature compared to that average over time, and notice that what's occurred from 23 to 24 is far higher than even during the last 10 years, if not certainly the last 100 to 150. And the reason for that may well be because fossil fuel burning leads to very poor air quality. Nations throughout the world have done a pretty good job of trying to clean up their air. China is one of them. The United States, I want to tell you what a success the Clean Air Act is. has been for the United States population. But burning of fossil fuels releases stuff in the air that blocks the sunlight. So there's less heat from the sun that hits the earth. If you remove that, which we've done a pretty good job of doing, then more of that heat gets trapped. Okay, the sun itself hasn't changed. It's the energy output, the amount of the intensity of sunlight. Just the amount that's reached there has. And this chart shows that. A fellow by the name of Jim Hansen, who's a climate scientist also at Columbia, who, something that it's kind of like, what was the name of the brokerage company that everybody said the minute they opened their mouth, everybody listened? He's that kind of guy. If he opens his mouth, you ought to be listening to what he says. And he's pointed this out and has put some numbers on it. The area in yellow represents the probable amount of increase in warming that has occurred since 2010. In other words, the rate of warming has gone up compared to the dotted line. The slope of the line has changed. The slope has increased by about 30%, 40%. So that kind of keeps me up at night. And I've spent a lot of time talking about temperature rise, but so what? Maybe we could move further north, but it's the all downstream effects of that, which are drought, flood, heat waves, biodiversity loss, which affects us as human beings in terms of our food, health, economic security, and political security. And as we demonstrated in one talk that we gave, that effect is not linear, that the effects accelerate over time with a given degree of temperature change. I'm going to have these people, Climate Interactive, which is an MIT group, has looked at that. And that with 1 degree, 1.5 degree C, which is where the UN and most climate scientists have fixated on as a kind of a kind of a break point. Notice that extreme temperature rises that can occur that we might be exposed to will be from 3 to 4 degrees. In other words, 5.4 to 8.1. An example of that, I lived in San Antonio in the 1980s. Very rarely did the temperature get to 100 degrees Fahrenheit. It was pretty persistent. And now it's routinely above 100. The number of days in which temperatures exceeded 100 degrees there has increased by, it's almost tripled, quadrupled. Here in Middle Tennessee, we have San Antonio weather now, the one I experienced in San Antonio in the 1980s. You could, Ken, you've lived here a long time. Jim, you've lived here all your life. You have too. You know what I'm talking about. We can talk about rainfall in a minute, but the climate has changed. And the temperatures that we see now are nearly identical, or at least the dry bulb temperatures, the temperature the Weather Service reports. This is the same as they were in San Antonio for me. That's anecdotal, but that's kind of what it is. And notice that if you increase it to 2 degrees, which is 0.5 degree, notice the droughts more than double in their length. And while maybe 10 to 15% of the world's population might be exposed to lethal heat, over 50% is. And then if you get to 3 degrees, Arctic sea ice is largely gone. And how that threat occurs or how that threat measure is the fact that sea level rise will occur and might occur rapidly. So at least in terms of how it affects us as people, here in the United States, economically, the number of billion-dollar disasters has gone up. That has not been constant. Obviously, it has increased starting in about 2010 to levels that have certainly put the insurance industry on its heels. How many of you all have looked at your homeowner's policy? You did. Did it go up? Yeah, mine went up 20%. Ken, you don't know. Jim, you don't have a mortgage. You probably don't. But Do you have a mortgage? And how much did your escrow account go up? You don't look at it. Okay. But mine went up 20%, which is the threshold by which I said, been with USAA for 30 years, ever since I was in the military. And I went shopping. Everybody else went up. In Florida, you can't, if you got a coastal property in Florida, good luck. You got a property in California, good luck. In some areas of California, explosive wildfire risk. How it affects human health. This unprecedented editorial said that the greatest threat to global public health was continued failure of world leaders to keep global temperatures below 1.5%. That's pretty graphic when 220 editors-in-chief of journals, of medical journals, all say the same thing. Ken's probably been on the editorial board of a couple of journals, and he probably realizes what an unprecedented event it is for 220 editors-in-chief of any journal to get together and agree to the same language. And one thing that we talked about is how these impacts interact with each other. And this graphic does that well because it shows that rising temperatures cause increases in water fall, increases in drought, increases in heat exposure, et cetera. That leads to changes in vectors, or disease vectors, and how we access water and how we breathe air and how we heat and cool our homes. And then a whole host of heat-related injuries, the climate effects and health effects of malnutrition and food insecurity and migration all interact with one another in somewhat both an additive and synergistic way. And this is kind of a wonderful graph that I look at. And the thing about all this, though, is that the poorest among us, and these two charts look at the per capita and the pollution of various countries in the world. The United States is up there, and on a per capita basis is up there as well. But these are the countries that will have less effect due to climate change. And the poorer countries among us will have the most. And that's just unfortunate. And the EPA has estimated what that would look like for poor and disadvantaged populations in the United States, with varying percentages of 15 to 20%, up to 30%, with regard to exposure of people in poor areas in this country to air quality, extreme heat, flooding, coastal flooding, and extreme temperature, and the fact that they themselves are more likely to be employed outdoors working in intense heat. So that kind of does the kind of effects, climate change, CO2, temperature, and downstream effects. And I want to go on and spend 10 minutes talking about what our faith says, because that's kind of what the focus of supposedly of this is. And at the end, I want to spend 10 to 15 minutes having a discussion on what we as a faith community ought to do. All right. So what do Americans, particularly professionally Christians, think about all this? Well, what do Americans say? And this is a graph that shows people that say that they're alarmed, concerned, or moderately thinking about climate change as a problem and consider it such, and compared to the percentages of people that just don't pay attention to it, don't believe it, or try to invent reasons as to why we ought to not worry about it. And notice that on the average, about 70%, 65, 70% of Americans say, I'm concerned about climate change, with about 60% of them saying, 55 to 60% of them saying, I'm alarmed or very concerned. We need to do something about it. However, when asked the question, does climate change a faith issue, a religious issue, with religious and faith being synonymous here? 10% of people in the United States say that. And what's striking is, what do people who identify as Christians say about this? Now, this is a very confusing graph, and Ken's going to mark me down for putting an awful lot of data on one slide that you can't see. But the top part of that shows that all Americans, if you put them together as a group, 61% of them think that it's due to fossil fuels. They're concerned about it. They want to do something about it. Now, if you look at religious unaffiliated people, that proportion is higher, which means that the people who are religiously affiliated, the proportion's lower. That's striking to me. And in fact, people that report themselves as evangelical Christians, only 30% of them think that it's due to us. Only 30% of them. And these are becoming more and more mainline Christian denominations. Now, we considered a mainline Christian denomination. There are a higher proportion of us that view this as a problem. But still, there are significant numbers of us that don't. And I'll give you an example of that. I've got a good friend of my wife's, whom I'm a friend with, who is a devout Catholic. She does not believe that climate change is real and it's just part of the natural cycle and that God will take care of her. That's what she thinks. And here I'm going to say that Will Wellman and Nate Stuckey would disagree with that. I think we in this room disagree with that, but that's what it is. And in fact, if you look at people who identify themselves as very religiously oriented, in other words, their faith is either the most important thing or one of two or three very important things to themselves, they are more likely to say it's not a problem. And if you look at evangelical Christians as an example, perhaps, we're going the wrong way with this group. Look at the graph to the right. The orange dot is what people said in 2014. The bluer dot and now. And can y'all still hear me? Yeah, good. Or what they're saying now, and notice that it's gone the wrong way. So, go figure. Well, what does our faith say? There are two major themes. We're called to take care of the world and be a part of it. That's kind of the Old Testament vision. We are called to help the most vulnerable upon us and to not do our fellow man harm. That's kind of the New Testament version of this. Now, Will Wellman would be in here thinking, oh, I don't know that I would make that division. This is Curtis Baysinger making that division. So you can take that for what it is. A fellow by the name of John Houghton, who was the Cambridge professor of geophysics and geoscience, who was lead author on the Interplanetary Committee climate change reports, winner of the Nobel Prize, is a devout Baptist and Presbyterian. And within these particular quotes, certainly gives justice to what the Old Testament theme is. Some Christians have misinterpreted dominion given to humans as an excuse for unbridled exploitation. However, the Genesis chapters do other parts of Scripture insist that human rule is to be exercised under God, the ultimate ruler of creation, and that we are to be the gardeners of creation rather than the overseers of it in that sense. The New Testament theme is along the lines of that human action causes climate change. Climate change does harm both to God's creation and to us and to others who are least able to defend themselves from it. And that this harming of others, it violates one of the central themes of the New Testament. We are not to do harm to others. We're to help our fellow man. Allman, he came in the on this, emphasized that, and I just wanted to relay what my summary of what he said was. He said, "The earth is the Lord's, everything in it, the world and all who live in it," from Psalm 24:1. And then he said that particularly the Old Testament needs to be looked at through could be looked at through three perspectives: egocentric, ecocentric, and theocentric, with the egocentric being that humans are at the top of the heap and it's ours to exploit, and theocentric being that no, God is in control and we need to listen to what he says. Uh, and then he did that through looking at what the Hebrew words meant to the people at the time the Torah was written. And it meant that dominion, the word rada, conveyed the word of responsibility. So that when you read Genesis, it ought to be fruitful and increase in number, fill the earth and subdue it, which means to bring life over death in it, to cultivate it, rule, in other words, take responsibility over the fish of the sea and the birds in the sky, etc. On the New Testament part, he says that Ezekiel tells us in graphic terms how not to treat our fellow man. Why do you trample the feet or the pasture with your feet so that my flock can't eat upon it while you're feeding your flock? Summarizing that from the Oliver Wendell Holmes quote, do unto those downstream as you would have others upstream do to you, which I think is kind of an interesting fisherman's approach to this. And Nate Stuckey also did the same thing, emphasizing that we are from dust. We have been created from stardust. God did it that way. He declared creation good and used the same sort of words and the Hebrew words to emphasize exactly what that meant at the time the people of the Torah wrote that down. Now, I promised everybody here to say what other faith groups say. And if you look at at least their national and international sorts of things, they all say the same thing. The books of the Torah, those of the book, which I include the Jewish, Christian, and Muslims, all say the same thing and cite passages from the Old Testament that reinforce that. Other Christian groups who don't particularly have a book to refer to, the Unitarians, I did include the LDSs in here, even though they do look upon our Bible, they are a Christian group. I included them because they tend to be the least among main faith denominations that support the idea that climate change is something that we should worry about. But the Unitarians also say that all life is interconnected, that our consumption of fossil fuels threatens life for generations to come, and that it harms the marginalized in our communities. Eastern religions also say that both Hindu and Buddhism, in their national and international statements, say that rapacious exploitation of the planet has caught up with us. We cannot destroy nature without destroying ourselves. Though climate change was certainly not on the Buddhist list, which is what Buddhists always refer to, humanity has to act on the root causes of climate change, and that lack of concern about the consequences of our actions will destroy the creation that Buddha refers to. I'm at a point now that we're getting towards the end here. So we have spent a lot of time, at least we did in a couple of sessions, talking about what we can do as ourselves and what we can do as both individuals and in groups and and in the congregation. And I just want to point out just a couple of things, and I'm rapidly going to do this because I want to get to the end here and have a discussion. The first thing, that the greenhouse gas emission of an average 16 tons. Like we at the higher end, if you are at the higher end of the economic food chain, emit more. Okay, Mary and I've calculated it for us. Between the two of us, we emit about 40. So we emit about 30% higher compared to the average American as an individual. And if you look at this pie graph, notice that there are some things on here we can influence and other things we can't. Particularly the stuff you buy, estimated here at 26%, most, at least among us at the higher end of the economic spectrum, that's more like 40 to 45%. But there are things that we can do, and they're along the lines of looking at what we eat, how we eat it, how we move around, and what we do with regard to consuming fossil fuels in our own homes. What we eat matters. Just cutting out beef alone would have a significant impact. And if you look at the bottom right-hand side here, if you're a meat lover and you stop eating beef, then you've cut just about a ton and a half, 1.3 tons off of that, 1.4 tons off of that. What do we do about home and our transportation? It would be electrify everything. And we were having that discussion before the session started. And we should advocate for the cleanest energy your utility company can provide. And buy less stuff. I already told you the main driver for us at the higher end of the socioeconomic spectrum is to purchase stuff. I'm telling you, Amazon's not helping us with regard to that, is it? And now I can argue with you if I've decided to buy less stuff, whether Amazon is better than going down to Macy's at Green Hills was. If you understand where I'm going with this, there's some evidence yin and yang about whether or not Amazon is more efficient in terms of getting a given product to us than the other distribution system was. But we can debate that. But notice the stuff that we buy for the average American still consumes a very large percentage, and this is all Americans, would be that 16-ton thing. The stuff I buy would probably exceed that. It would exceed that for people who buy that things. Because the stuff we buy, we can't control very well. Calculate your carbon footprint and buy offsets. This is what I've chosen to do. I want to point out, though, that I've just skipped through a bunch of stuff because the question is, what do we do with others? What are we going to do with others if we realize we have a problem? And unfortunately, only a few of us are doing anything, either through our faith-based communities, with groups outside of that, or whatever. Then we've got 70% of Americans saying there's a problem. But if you ask them, half of them feel, or 35% of Americans are hopeless and don't know where to start. And really, only 8% of them are activated in doing something. And why is that? We talked a little bit about it. It's both about how we behave ourselves with regard to our own psychology, fear and guilt, and not feeling the effects as personal, and feeling them being far away tends to promote inaction on our part. And we tend to align ourselves in groups. That leads to group pressures that may tend to avoid us from doing things. What can we do? And this is the Catherine Hayhoe thing, is that the thing that you can do at the individual level is to talk about it. And I wanted to add one thing to that, to talk about it with others with whom we disagree. So one of them is to talk about it. We're going to talk about it here in a minute. But talking about it with other people with whom you disagree is tough, isn't it? How do we do that? And we do it in a manner that we realize we're not going to do very well in trying to change their mind. Because it doesn't, you all don't understand what I'm saying. Haven't you had a discussion with someone and said, I really want to try and change your mind, and you walk away frustrated from the conversation because you haven't done it? And that guy hasn't done it to you, has he? So how do you engage people to do that? There are ways of doing it, but the other thing is that you kind of have to commit yourself to doing it for the long haul. Potential Energy, which is actually a public, actually bipartisan group that looks at and surveys people across the political spectrum, came out with this thing. Based on our data, our best guess is the average person needs to see and hear about climate change at least 80 times a month. Okay, well, then that's over 3 times a day, right? It's like 3 times, it's more than, well, it's about 3 times a day. Now, you could join your voice in that and make others hear about it. So in light of all that, I want to spend 10 minutes and then we're going to be done because it'll be at 10 minutes before the hour. I wanted to consider three questions about what we should do here in our congregation. And if you want to talk about something else, I'm all ears as well. And I wanted to consider three things. Since I've advocated for talking about it, how can we talk about it here at Westminster better? What steps can we take other than talking about it to help deal with this? And then I'm going to ask you to consider this. Can you name one behavior? You don't have to name it now that you're going to undertake, perhaps pledging to talk to someone about climate change once a day, which is what I try to do. Now, by doing this, I've done, there are 8 of you in the room, including Alec, 9 if you include me. So I've talked to myself. I've now covered myself for 9 days, right? I've talked to 9 people, but now I'd like to say that I've only talked once today. I probably will talk to somebody tomorrow as well. So let's just talk about that in any order that you like. And so how can we talk about climate change better here at Westminster? How would we do that? I'm sorry? Yeah. Right now, we use a lot of cars, we use airplanes, primarily for the country, I think. To be better, there's no real which is electric car, really making a big difference. Putting light capture rate, light, like sunlight. Is that how we can spend it? Looking a little bit about what the Anybody want to comment on Ken's question or? Yeah, you and then you, yeah. No, buying electric car, hybrid car, or regular gas car. I can show you a graph of that, but I don't have it with me. Depends on the car you have, the train you take, and the plane you fly, okay? And how far you're going, right? So, rule of thumb, if I'm going to travel to St. Louis, where my granddaughter lives, and Mary and I are going together, then in terms of CO2 emissions, driving our car that gets 30 miles a gallon on the interstate does better than for the 2 of us getting into a plane. If it's just one of us, the plane's a wash. That's one question. Your second question, part of your question, individual choices that you can make. Your second part of the question was about what policy questions do we do at the governmental level to do that? And I don't have that in here, and I do have a simulator program that helps answer that question. And I'm going to thumb back through this. Yeah, right here. There's a product that the MIT people put together called En-ROADS. Just remember En-ROADS. Everybody has a Google search engine or access to it. And I'm sorry, you have a question, you were going to say something, but we'll get back to you immediately. But at any rate, I want you all just to look at this one thing I thought is that if we'd had time, I would throw it up there and we could try a few policy things. But this will answer your question, Ken. En-ROADS, it's very easy to use. You just move sliders across their interface. And you can explore various policy questions. For example, does exactly what you said. Does electrifying transportation make a significant reduction in CO2 emissions? And it will help you answer that question. And the answer is that electrifying it alone doesn't, because you don't change the fuel mix very much that provides that electricity. And in fact, you may actually increase emissions, the point that you made, because you got to keep more coal-fired plants online in order to spread out those electric cars. Now, the most effective one in this, if you had to single out one policy, one, would be to tax carbon. In other words, put a price on it. But what do you do with the money? Because that's going to generate a lot of money. In fact, we're talking $2.5 trillion. You mean you're going to let the federal government have access to an additional $2.5 trillion? I don't think. No, you give the money back to everybody. So you and I get a check. So now, boy, I get a check of $400 or $500 a month now. You know, in 6 months, I've got $3,500. Oh, my heating and air unit just went out. Oh, I'm not going to use that gas pack anymore. I'm looking at the fact that the cost of that gas is going to continue to go up. Now I'm going to go buy a heat pump. Yeah. Oh, I'm sorry. Yeah, I'm sorry. Do you understand why I advocate for a carbon price? But you can, this simulator here lets you play with those. Okay. And in fact, we use this. I'm a member of Citizens Climate Lobby. I've tried now for 1.5 years to get into Haggerty's office to present this to them so that they can make meaningful decisions about what United States policy on energy ought to be. But the guy's so driven by, I don't want to get into that. I can't do it. I've requested to keep doing it. We actually have gotten into Blackburn's office. Her energy aide was interested. So she actually gets a check mark for that, in my opinion, even though, but at any rate, I'm sorry, go. You. Carbon capture is not technically ready for prime time. It's too expensive and probably will not be economically viable by until the mid-1930s. The most important thing that we can do is to generate as much renewable energy or carbon-free energy. I don't particularly care what it is. The Inflation Reduction Act did a lot of that, provide carrots for that. It's not enough, but it will have a substantial impact. Yeah, but if you do, if you go ahead though and give money back to the people who are the consumers of it, particularly industry, the equation changes because industry is, and you and I might change, you know, but that's why a carbon fee and dividend goes to address the second part of that question of what happens to increasing price. Well, demand falls. And if you give people a choice now to spend their money in a different way, which the dividend does, then you do drive. I'm trying to answer your question as to why. Your point is a very good one. All it does is increase the cost to us as a consumer. And you can make very effectively the argument that that does hurt people in the lower socioeconomic spectrum the worse. But you give them a check, that's different, you know. And I can get into the weeds a little bit more, but I want you to your question is an extremely good one, but I want you to think, I'd just ask you to think about it in terms of if a carbon price was in place and then you gave money to people to be able to deal with a higher cost of fossil fuels, how that might improve that. Yeah, Carol. Part of the problem is trying to equate environmental effects other than greenhouse gas emissions from the effects of mining itself. And so what are the environmental hazards of mining lithium, cobalt, stuff that's not normally mined now, compared to the environmental effects of mining, iron ore, pumping oil out of the ground, the manufacturing environmental effects of automobiles without batteries. We've made the assumption we're going to drive around in something, right? Ken said, should you do public transportation? I wish that would. It's too expensive. Why do you think the bond issue in Nashville got shot? It's too expensive. So I'm just using it. I'm giving you my opinion. But anyway, made the assumption either part of the what are the environmental versus and most people are saying the environment given the fact that even though others most people say that's a very mistake. There are people that go wrong. Most people study. And I just wanted to show this to you because it really gets at the heart of it. And if you look at the thing to the far left here, notice that over the entire lifetime of an EV, at this moment, that you could produce about 40 tons of CO2 over the lifetime of driving it, putting the electricity at the given percentage of renewable energy in the United States. That's very important because this changes. It changes into the future. First is an internal combustion engine, which is about 55. So you're talking about going from 55 to 40. And you say, well, maybe that's not that great a deal. However, if you look at the CO2 emissions with regard to battery manufacturing in the battery, as industry reduces the amount of CO2 emissions required to manufacture them, that will go down. Same thing is true for the internal combustion engine. However, the fuel itself is where the greatest savings in terms of CO2 emissions occurs. Okay? So we can expect at least the changes that might occur in the future for the life cycle emissions of electric cars to decrease from this 39 number. And you can expect that the CO2 emissions from internal combustion engines are largely not going to change. So does that help answer your question? And these numbers are from we're still worried about money. That creates knocking effects that are greater than each of the relative. Listen, thank you all for coming. I appreciate it. I hope it's been helpful. And we'll just continue the conversation. Hopefully we can do it on a Wednesday night. I think what I'm going to do, Ken, is please look at this inroads thing and see what you think. It's a lot of fun. I mean, it's not like watching your grandchildren play. That's real fun. But I mean, it's kind of fun. It's interesting. It's like going to the movies or something. So, I